All right, so this time we're going to use our graphing calculator. So where you start is by taking that function and putting it into the y equals menu. So you're going to push y equals, of course, after you turn your calculator on. There's the on button, in case you didn't know. So then you're going to plug the function in into the y equals menu. So you're going to ignore the equals 0, and you're just going to plug it in as y1. Okay, you can plug it in as a different y, but usually we'll use y1 there. All right, and probably good to clear out anything else you have there. All right, so let's talk about the table. If we want to use the table, then we're going to go to second. You can go to table set to change some settings on your table, but I would just go second graph, and that gets you the table, and that's probably the fastest, easiest way to get there initially. Actually, let me show you one thing first. Before you go to table, just go to graph. So instead of doing second table, and you might have already done that, and that's fine too. Just push graph if you're at the table, and just push the graph just so we can see that, because that's probably the best thing to look at first, because sometimes you'll see that there's no solution, right? You'll see that's obviously never going to cross the x-axis. Then you don't have to waste your time with looking for a table or whatever, or a solution. So we look at the graph, and we can see here, and my calculator isn't as clear as this because I have the older model, battery operated, and so it's a little tougher to see, but we can see that it doesn't cross exactly on a tick mark, right? It doesn't cross on an integer value, so it's kind of in between. And so and we can see that it's probably between here 0 and 1, and here let's see, 2, 3, 4, 5 and 6, right? Just like we thought about, or just like we figured before. All right, so anyway, now that we see that they don't cross exactly there, if we want to get a little more precise, now we can go second graph or table, and that'll get you this right here, right? And yours might start, I think by default you'll start at 0, so you'll see 0 at the top. So I just pushed the up button a few times, and kind of got it to where it's balanced here. And the reason I did that is because you can see this is the nature of our parabola, right? It's symmetrical. You can see all these values repeat down here, right? And so so you can see this is actually where the vertex is, 3, -5, right? Or at least it looks that way, right? We can't be totally certain of that, but it looks that way because that's the middle, or that's the lowest it gets, right? That's our minimum value, -5, and then it starts going back the other direction, right? Okay, so it goes up in both directions, and this is its low point or minimum. So now let's look for zeros. So zeros are where we go from negative to positive, or positive to negative, right? So we can see that we have all these negative values here, and we go from negative to positive somewhere in this range, right? Let me use a different color here. Somewhere in here, right? Between 0 and 1, and somewhere in here between 5 and 6, just like we thought before, right? If we want to get more precise, we can actually change where it says delta table. That changes the scale. So instead of going by 1 unit from one element to the next, or one input to the next, we can actually change it to go to the tenths or hundredths or whatever. So the way to do that is, you can see right here it says press plus for table. You can also go second table set to do that, but it's a little easier once you're in this menu just to push plus. Okay, so go ahead and do that, push the plus symbol. Let's see, mine is right here. So push the plus symbol. And then for me, I typed in 0.1, enter. You can do it to the nearest hundredth if you want to. But anyway, yeah, so as precise as you want to get, I did 0.1 as my increments. So you can see now, and I scrolled a little bit to get here, but get back to here. But you can see now that these are, the increments are 1/10, right? So instead of going from 1 to 2 or 1 to 0, it's going from 1, 0.9, 0.8, etc. All right. And then you can see that, of course, our outputs are going to be more precise as well. So I'm looking for, okay, where did it go from negative to positive, right? And that happened in here, in between these two values. So So if I want to be more precise, it's between 0.7 and 0.8, right? If you want to get to the nearest tenth, it's between 0.7 and 0.8. And you could scroll down to find the other one, right? Because it's going to go negative, and then it will hit the vertex and go back up towards the positive values. Now let's say that you want to find a different way to get it exactly right, where you don't have to kind of scale up and down a table or create a table. Then we have a way to do that on the graphing calculator too. And this is probably the way that I recommend if you have a graphing calculator. This is probably the best way to do it. So I think it's the most efficient way to do it, and probably the most precise way to do it. So you're going to go second, and this is after putting the function into your y equals menu, right? So you still have to put in the y equals, and you can still check out the graph. And then if the solutions aren't easy to find just by looking, or if you know there are solutions, but it's hard to see them just by looking at the graph, then you can go to second, trace, and that's our calculate menu. And we've used this before, right? That'll get you here. And we've done this before, right? We've used the value when we're using scatter plots, and we're just trying to find, hey, what if the input is this? Then what's the output? That's what value does for us, right? We've also done intersect when we're solving systems of two equations, of two linear equations. But now we're going to do 0, right? So we want to find the solution, the zeros, the roots, and so the x-intercepts. And so that's how you do it, is you go second, trace, and then you're going to go number 2, okay? So second, trace 2, and what you'll get is, wait for it, what you'll get is this question here. Here it is. And it'll say left bound, question mark, right? And so basically what that is a calculator needs to have functionality. We talked about a function is where you have one output for every input. Calculators have to have that, because if they don't, it'll just loop forever. And so your calculator knows that, hey, sometimes you're going to have more than one solution. So if it's trying to find a 0, it's trying to narrow it down and say, which one are you talking about, right? And so that's why it will do this series of questions here. So the first question is left bound. So if I want to find this 0, then I want to move this cursor here anywhere to the left of the 0 that I'm trying to find. So you can put the cursor anywhere on this side of the line, okay? All right, so I'm just going to keep it where it is and push enter. It doesn't really matter how close you are, so don't get too caught up in exactly where it has to be, just somewhere on the left of what you're trying to find. So I'm just going to push enter there since it's already on the left. Then you'll get this screen where it asks you right bound. Okay, so remember, we're trying to find this 0. So now right bound, we want to be anywhere on this side, anywhere on the right, but we don't want to go too far past. We don't want to get to the next 0, because then the calculator is going to be confused and wonder which one we're talking about. Okay, so you want to be to the right of what you're trying to find, but you don't want to go past another 0, because then your calculator will be confused. Okay, and by the way, you can see this little arrow here, and that's after you push 1, it'll have an arrow pointing. After you push your left bound, it'll have an arrow pointing from left to right. And then now I'm going to get my cursor anywhere here. I'm going to press enter. Okay, and then we'll see. Now we have another arrow up here, right? So you can see my calculator doesn't do this because I have the older version, but if you have a newer calculator, you'll see these lines where it actually kind of encloses the area that you're looking at. Okay, so but anyway, you want to make sure that the 0 that you're looking for is between those two arrows. Okay, so make sure it's between those two arrows. So anyway, now it's going to ask you one more question, which is guess. And so once again, it's just trying to narrow down the 0 that you're looking for. And so just try to get as close as you can. It actually really doesn't matter as long as you did the first 2 steps right. You can really just push enter on that step and you'll get it. Okay, if you have 2 zeros in between these arrows, then you might that's when it might be a little more critical to guess. All right, so anyway, I'm just going to push enter again. Okay, so left bound, get to the left, push enter. Right bound, get to the right, push enter. and then it'll say guess, and then get as close as you can, and push enter. And what you'll see after that is a solution. Okay, so it'll say 0, and then it gives you the value for x. Okay, and then of course that's where y equals 0, right? So that's an exact value, or not exact, excuse me, but more precise, right? It's rounded at least to the to 1, 2, 3, 4, 5, 6 decimal places. So we'll just say x is approximately 0. Let's do the nearest hundredth, so 0.76. Okay. All right. So now let's do the same thing for this other point. Okay. So go ahead and do that on your calculator. So I want you to go. You're going to go second, trace, or that's calc menu, and then 2, and then you're going to go left bound. So you want to get it somewhere here on the left side. So left of what we're trying to find here, but not too far left. You don't want to go past the other 0, right? Because then it's going to get confused. So then push enter when you get somewhere in here, and then it will say right bound. So then you want to get anywhere on the right side of that 0. Push enter, and then it will say guess, and so then you want to try to, get fairly close and push enter again, and see what you get. All right, so you should have gotten this. Okay, and so this is our other value here. Now I want to point out, sometimes this will come up. It depends on what your calculator settings are, so you may or may not have gotten that. But if it says e to the negative some power, that's basically saying 1 times 10 to the negative 12th power. It's like a shorthand scientific notation. And so that's basically 0.00000. It's a point with 11 zeros and then a 1, right? So it's a super small number. It's actually just essentially 0. It's an infinitesimal, and so it's actually 0. Or but your calculator just was a little bit slightly off on getting it to 0, and so, but for all intents and purposes, you can just think of it as 0. Y equals 0. Okay, so, and as far as what we're doing, especially rounding to the nearest hundredth, that definitely gets us close enough to where we have that precision that we're looking for. So 5.24 in this case, we had to round the 3 to a 4, and those are our two values. Okay, so that's how to use your calculator to get there more precisely. So you put it into the y equals menu, then you go second, and after, look at the graph first, but after you do that, second, trace, 2, left bound enter, right bound enter, guess enter, and you'll get your values, and you'll have to do that twice a lot of times if you have 2 solutions.